Stay classy, Golden Eagles. So guys, this is going to be the last video lesson of the week. Previously in the week, you had worked on classifying angles by their sides and the length of their sides. The week before that, you'd worked on naming triangles, so triangle ABC, triangle BAC, and things like that. And you also worked last week on classifying triangles by their angles of by their angles. So today we're going to combine the last two, which is classifying triangles by both their angles and their sides. So our learning target today is I will be able to classify triangles by their sides and angles. All right, that is our goal today. So what you guys are going to practice today is you guys are going to practice with me one example problem. And what we're going to do is we're going to go through and we're going to tell the number of acute angles, the number of obtuse angles, the number of right angles, and then we're going to decide whether it's an equilateral triangle, a scalene triangle, or an isosceles triangle, okay? And your page that you're going to be working on is page 10. It's below this video link. And there's 5 problems and there's 4 categories, so there's 4 questions to go ahead and show for each individual one. So let's go ahead and take a look really quick. So this is a little bit of a different this is actually pretty similar to the example problem, but I wanted to kind of go over it. And your page is going to look slightly different. I kind of had to make my own a little bit. So this is the triangle, and we're just going to focus on these first couple for the first. But this is our triangle, and if it's a little, there we go, a little tough to see, there it is. So the first one that we're going to look at is the number of acute angles. Now, acute angles, if you guys do not remember, are angles that are less than 90 degrees. And a 90-degree angle is when two perfectly straight lines meet up at a point. That's a 90-degree angle. If it's acute, it's less than 90 degrees. So it's somewhere between here and all the way down to here. Okay? And a reminder of an obtuse angle is greater than 90. So if this is 90, it's going to be anything greater all the way down to as far down as you can get your forearm to go. And that's as far as I can get. So acute is less than 90. Right is exactly 90, and obtuse is greater than 90. So looking at this triangle, we're going to answer this first question. Okay, let's look at this. So is this less than 90, greater than 90, or exactly 90 at this vertice right here? You're absolutely right, Sam. You're right. It is an acute angle. So that's one acute angle. So we looked at that one. Let's go ahead and move over here. So looking at this one, remember, we're looking for acute angles. Acute angles are less than 90 degrees. I did my best to make these two perfectly straight lines to match up, so it's actually a 90-degree angle. And sometimes you'll see a 90-degree angle indicated with a little box in a corner at a vertice. So that's actually a right angle. Okay, number of right angles. We got one over here. And I'm just making tally marks, and then I'll make a final number after I count them up. And then we look at our last one, this one up here. Remember, obtuse is greater than 90, a right angle is exactly 90, and an acute is less than 90. So if it were 90, a line would come here and go down like this, so it's not 90. And if you look at it, it's certainly not greater than 90. It would be over there if it was greater than 90. So yet again, it's another acute angle. So I'm putting a tally mark. So we've looked at all 3 vertices, or a meetup where angles exist. A vertice, if you remember, is where 2 lines meet up. So 1, 2, 3. Every triangle will have 3 vertices. Otherwise, it's not a triangle. So we counted up the number of acute angles as 1, 2. We found no obtuse angles because we have a 90-degree, an acute, and acute. And then we had 1 right angle. And if you guys remember from the videos from last week, you cannot have more than 1 right angle, and you cannot have more than 1 obtuse angle, and you can never have a triangle that has an obtuse angle and a right angle. The math just doesn't add up. The measure of inside of every single triangle, no matter what, is going to equal 180 degrees. So if you have a 90 plus 90 is a 100, and that's only 2 sides. It just cannot work if you have 2 right angles or if you have a right angle and an obtuse. And you can never have 2 obtuse because otherwise it just won't work because it's greater than 90, and 90 plus 90 already equals 180, and you still need a 3rd angle. Okay? So we have 2 acute angles and 1 right angle. Now we need to classify this triangle based on what we know. So the first one we're going to do is what we practiced last week, is we're going to classify it based on the angles, okay? So it is an acute triangle if all three vertices have an acute. We only have two. It's an obtuse triangle if you have one, only one, you can never have more than one obtuse angle. We have none. It's always going to be considered a right triangle if there is one and one only angle of vertices. So this is a right triangle. That's our first classification. Now our second classification is going to be what we worked on in practice this week. Whether identifying this as an equilateral triangle, an isosceles triangle, or a scalene triangle. And if you guys, just a quick review on it, that is based on the size of the sides, okay? So a scalene triangle has sides that are none of them are equal length. An isosceles triangle has two sides that are the same length, okay? And an equilateral triangle is where all three are equal, okay? And I'm looking at this one right here. And, you know, guys, we don't have tally marks on this, and I'm not going to put them on there because your examples don't. I'm just going to use my eyes and use my best judgment to say, this is my shortest side. There is no side that is, this side does not equal this one or this one, okay? So instantly, that tells me since this side does not equal the same length as this side and this side, that it is not an equilateral triangle. So now we're down to it's either going to be a scalene, which means that no sides are the same length, or an isosceles that two sides are the same length. So since we already identified that this one does not equal either of the other two, we can kind of forget about this one. Now let's look at our two remaining sides. Now they do look close in terms of size, but if you measured them, and if you notice, lines are longer when they go diagonally, traditionally, as opposed to a straight horizontal line. So I can look at this one and say that, in fact, none of these sides have equal length. So this is a right scalene triangle, meaning it has no sides that are of the same length. So by the end of this, we have identified that this triangle has two acute angles, this angle and our angle at the very top. It has no obtuse angles, angles that are greater than 90 degrees. Oh, quick reminder, an acute angle is less than 90 degrees, so this is less than 90 and this is less than 90. And we have exactly one right angle. Therefore, since it has one right angle, it's a right triangle. And since it has no sides that are equal in length, it is a right scalene triangle. Okay? Guys, if you have any questions on that, go ahead and send me an email, leave a comment below. Go back and watch the previous videos for these that help to explain it maybe a little bit more in depth. If you're going to use the Zoom, not the Zoom, my mistake. If you're going to use the Khan Academy video, remember that the teacher there doesn't say classify, uses the terminology category. They are synonyms, they are the same thing. Make sure that you guys are asking questions, doing the work, hitting the submit button when you're done. As always, stay classy, Golden Eagles.